Okay, let's talk simplifying radicals and what we mean by a radical. What we mean by a radical is this symbol. Okay, it's different than this symbol. This is divide or quotient. This one is the radical symbol. Okay, many of you know this one as a square root. But there is also these other radical symbols, and it keeps going. Okay, so we have third root, fourth root, fifth root, sixth root, seventh root, sometimes known as cube root. Okay, so this one's square root. The reason it's square root is there's technically a little 2 right here. This little number right here is called the index. And the index tells you what root you're doing. If you don't see one, it's an understood. Like when we have x, it's understood that it's 1x. And it's understood that it's 1x to the first. And it's understood that it's 1x to the first divided by 1. All of those 1s are understood. We don't put them. We usually just put x. Same thing with square root. If it's not a third, fourth, fifth, sixth, seventh, eighth, ninth, keep going root, then it's the square root. It's understood. Now let's talk simplifying roots. I'm going to show you with square roots, and then I'll show you a third root, and then any other root is all the same thing. You need to be able to do them by hand because not all roots are easy and perfect. Not everything is a 1 or a 4 or a 9 or a 16, a 25, a 36, a 49, and so forth and so on as you square all these numbers. Roots and square roots are opposites. Like multiply and divide are opposites, and add and subtract are opposites. Square and square roots are opposites. Cube and cube roots, fourth and fourth roots, fifth and fifth roots. They undo each other. That's how we are able to get rid of those exponents in PEMDAS when we're simplifying and reversing it with SADMAT. So here's how we're going to solve these. The blue and white little baby calcs, the TI 36XS or 30XSs or whatever they are, they'll actually do simplifying square roots for you. Okay, they reduce the radical. But if you get above a square, you can't do it. We will get there. So we want to be able to do it by hand just in case. So let's take one we know. The square root of 36. Most of you will probably go, oh, well, that's 6. It's very easy. I know. 6 times 6. And that's what we're looking for. Remember, this index is a 2. And so what we're... hello, not that. And so what we're looking for is square roots. Okay? So what we're going to do is factor tree. We're going to factor out 36 until we find things that are squared. If they're squared, the thing that is being squared is the root. That's what comes out. So if we break 36 up, we know that it's 6 times 6. Now when I do a factor tree, I always like to cut the branch previous so I know that I cannot use that number for anything. That 36 is not 36 anymore. It's turned into 6 times 6. But what I have is something being squared. I have a pair. I like to say pair up, square up. If they pair up, square up, then it comes out, okay? So 6 times 6. 6 is being squared. So what is the root number that was squared to make 36? Well, that was 6. Now that can happen a couple of different ways. Let's say you didn't remember that it was 6 times 6. And maybe you just said, well, I know that 36 is even, so I know 2 goes into it. And I do the math, and it goes 18 times. So now I've turned the 36 into a 2 times an 18, but I don't have a square. I don't have a pair up, square up yet. So then I keep going. Well, 2 doesn't factor anymore, and I should always factor all of them as complete as possible if I don't have pairs yet. Just keep factoring. If you have pairs, grab them early. Makes your problem shorter. But I go 18. Well, that's even as well, and I know 2 goes into it 9 times, so no longer 18. So now it's 2 times 2 times 9. Well, look, I got a pair. So I know a 2 is part of the root. A 2 comes out. I have a 9. It is breakable, so I'm going to factor it. It factors into 3 times 3, and oh, look, I got another squared thing, another pair. So a 3 also comes out. Now, all of these things are factors of, so they're multiplying. 2 times 2 times 3 times 3 makes 36. So what are the roots that are being squared? Well, 2 was being squared and 3 is being squared. So I pull one of those out each because that represents the root. And 2 times 3 is 6, and we're still back at the answer. But let's say maybe you went a different route. Maybe you said, well, I know 3 goes into it because 3 plus 6 is 9, and 3 goes into 9, so I know 3 goes into 36. That's the trick for knowing if something divides by 3. Add the digits. If that's divisible by 3, then it is. So maybe you said, okay, well, it's 3 times 12. Well, I don't have a pair yet. Okay, so 3 can't break. It's prime, but 12 can break into 3 times 4. Ooh, and I broke that branch, so then I've got a pair there. And 4, if I just wrote it as, okay, well, I pulled a 3 out, and I got a leftover 4, and I said, okay, well, 4 had to stay inside. Well, you need to double check that because 4 has got factors, 2 times 2, and ooh, it pairs up, and it also comes out. So I got 3 times 2, which is 6. Okay. When you have a leftover, like the 4 that we had here, it just stays inside. And if you have more leftovers that are not factorable and don't get you any more pairs, you just multiply them together back underneath. Just like on the outside, you multiply them together. Okay. Ooh, let's pick green. And so maybe 36, you did 3 and 12, right? And then you said, well, 12 is like 2 and 6. And I still don't have any pairs. And 6 is like 2 and 3. Well, I got a pair of 2s, but I also have a pair of 3s. So a 2 comes out, a 3 comes out, and it's still 6. Okay. So let's look at another example. Let's look at something like 54. Let's see, 54 is even, so I know 2 goes into it, but I know my times table, so I know it's 9 times 6. All right, well, the 9 breaks into 3 and 3. The 6 breaks into 2 and 3. I have a pair of 3s here, but the 2's alone and the 3's alone. So when I go with the answer, the 3 that squared up, paired up, comes out. But the 2 and the 3 that didn't stay inside, so that reduces to 3 squared roots of 6. That's as far as it goes. Let's try another one. Let's do like 500. Oh, it's really big. Okay, so maybe you see that very easily that, well, that's 5 times 100. And then 100, you see that's 10 times 10. Well, I can stop right there because that's a pair. And all I have left is a 5, and that's prime. So it's 10 comes out, that's the pair up, square up, and the 5 stays in. Just like that. And maybe you didn't see it that far. Maybe you're like, well, you forgot that 10 times 10 is a pair up. And then you just decided to go, okay, well, that's 2 and 5. And that's 2 and 5. Well, you got a pair of 2s, and you got a pair of 5s. And so 2 comes out, and a 5 comes out, and a 5 stays in. And 2 times 5 is 10. No matter what, you get back to the same place. Okay. Now, what if it's not a square root and you can't check it in the blue and white little calculator? Because what if it's a cube root? Well, a cube root, the index changed. We were looking for pairs and squares, pair up, square up. Okay, so now we're in cubes. So all we got to look at for is triples. So we break 16. Well, I know it's 2 times 8, right? That's one way to think about it. And 8 is 2 times 4, and I could circle those 2's, but I only have 2 of them, and I need 3 of them. Very important. So let's break the 4 apart, 2 times 2. And now I've got 1, 2, 3 2's, and I got a 2 left over. So a 2 comes out, that's my 1 cube thing, and a 2 stays in. That's my little loney. So the cube root of 16 is 2 cube roots of 2. Don't forget to put your index back in your answer. And that's how you reduce radicals.